All right. Please, this top left part of your notes, cut it in half. We are going to talk about inverses both with just regular numbers, and then I'm going to use that information to flow into inverses matrices. Um, the reason why we are talking about matrix inverses today is it's something that we will use in a few days to solve equations. But first, we want to just work with basic inverses so that we have that skill down when we want to solve. If I gave you, so we're going to do numbers. We're going to talk about inverses with just regular numbers on this side and matrices on this side. That says matrices and the letters all flow together. Okay. If I gave you 5x equals 10, how would you solve? You would divide by 5, right? We're here. Okay, I know, we're focusing, I know. The reason why you divide both sides by 5. We do. But the concept behind that is dividing by 5 is the opposite of multiplying by 5. Okay? So division and multiplication cancel each other out. That's what we call inverses of each other. So another way we can, so follow me how I'm going to rewrite this. I'm going to rewrite this as 1/5. You're okay so far, right? I'm just dividing by 5 is the same as multiplying by 1/5. Another way we know how to write 1/5 is like this. Remember our negative exponent rule? Right, you would flip it and you make the exponent positive. And what do you think happens right here? The inverse of 5 times 5, what will those do to each other? Cancel, leaving you with just x. Okay. So I had that written like that for a very specific reason. There's a reason I didn't just simplify it to 2. So this is, we solved an equation by multiplying both sides. We did the inverse operation to solve. Here's how that would look if we're talking about matrices. Remember that capital letters denote a matrix in this unit, okay? Matrix A times matrix X equals matrix B. And similarly to this last step, or this one right here, this middle step, if I multiply both sides by an inverse, I could solve for X. What would I be taking the inverse of, do you think, A or B? A, right? Because it's the one that's being multiplied by X. So if I multiply both sides by the inverse matrix, what do you think happens to A inverse and A here? Cancel. And I'm left with matrix X equals the inverse of matrix A times matrix B. Okay, and this is sort of, this is why we're even talking about matrix inverses in the first place, so that we can eventually solve equations with them. Because you cannot here divide both sides by matrix A because it's not defined that way for matrices. So what we have to do instead is figure out what the inverse is and multiply both sides by that. Okay, and that's how we'll solve. So the next question becomes, on the upper part of your notes, how do we find the inverse of a matrix? Okay, again, why do we care? Because it's going to help us solve eventually. How do we even do it? So I'm right here. We set up something like this. We take whatever matrix we're given, we multiply it by some variables, and so if I had this matrix A, and I had variables, meaning it's unknown, right? That's my X. If you multiply something by its inverse, what would you get? Like when we did 5 times 1/5, what did we get? 1, right? So when you're multiplying inverses together, you get 1. I put this here. I don't really want this here. If you wrote that AX, you're free to... Oh my gosh. Use pencils. It's math class. But 1... But we're dealing with matrices, so even though I know you conceptually understand that that's a 1, right? Something times its inverse is 1, but we don't just have 1 as a matrix. What we have instead is something called the identity matrix. So look how I'm going to change this 1. Are you ready for I'm going to change it? I made it an I. I stands, it's a capital I, it means a matrix, it means the identity matrix. Because you can't just put a 1 there. What you have instead is a matrix where there are 1 on the diagonals and 0 everywhere else. So in matrix land, 1 looks like this, okay? In matrix land. What do you think in matrix land? Yeah. 1 for 3 by 3 would look like this. You have 1s on the diagonal and 0s everywhere else. It depends on the size of the matrices in your problem. Determines which size I matrix that you need. Okay. So just know that inverses multiplied together give you 1, but in matrices, 1 looks like a matrix with 1s on the diagonal. Okay. Which is why we defined diagonals previously, so we know what we're talking about. Thank you, Sue. Okay, and so the way that we find it is we solve that equation, which is something we'll do on the bottom right. This example for this question is on the front of your notes. It's at the bottom right. We'll get to that tomorrow. It's good that we talked about it right here. We'll talk more about it tomorrow. The next question. How do we even determine whether two matrices are inverses? So this is, I'm sort of shifting gears. This one is how do we find the matrix, and we would have to do some solving. This one is, okay, you've already been given two matrices. Determine if they're inverses of each other. Okay. Well, if they were inverses of each other, and I multiplied them together, what would I have to get if they were inverses? Inverses multiplied give you 1, right? So if you're given, so this is what we would do for number 2. We would multiply them together both ways. Do you like both ways or both directions? Which one makes sense to you? Like if I did A, B, and B, A. Ways make sense? Okay, it's also shorter to write. Multiply them together both ways and see if you get I matrix, which is the identity matrix. So basically, if I gave you two matrices, A and B, if you multiply them this way and this way, you have to verify both directions, you would get I. What time are we getting out of here? I know y'all told me, but I forgot already. 25, okay. So this example for this one is on the back, so we're going to flip to the back. And then we're going to leave the other one, which is quite a treat, for tomorrow. Does anybody need the screen up anymore? Okay, so go to the back. Oh, don't look. Of course, I said don't look, so obviously you looked, I'm sure. Okay. So we have these two matrices, A and B. We want to know if they're inverses of each other. This is what I'm going to verify or try to determine. So here's what we're checking out. We're going to do two different problems. We're going to do matrix A times matrix B and see if it equals the identity matrix. And what else do I have to do? B times A, right? Because remember that matrix multiplication is not commutative, which means just because you switch the orders doesn't mean you're getting the same answer. So you have to check it both ways. So I'll do AB for you, and then I'll let you do BA in case you need a refresher on matrix multiplication. If you are already a ninja on matrix multiplication, just don't even listen. Just do your math, okay? But here's A times B. A has to get written first. And then here's B. So what do you think are going to be the dimensions? They're both already 2 by 2. 2 by 2. So I'll kind of do this in detail in case you need to see it. So for this one right here, first row, first column, I'm looking at the first row and the first column. Everyone good about that? Okay. So I'm multiplying negative 2 times 5.5. That's negative 10 plus 1. That's negative 11. That's the first positions. Then the second positions. Negative 6 times negative 2 is positive 12. And it just so happens I have 4 different colors of highlight. If I were to do next the first row, second column, in my answer matrix, that's right here. First row, second column. The first thing here times the first thing here is negative 6. The second thing here times the second thing here is positive 6. And then I always go back down and then from the left again. So now I'm going to look at this answer here. Okay, second row, first column. So I need second row here, first column here. First thing times first thing. 4 times 5.5 is 20, and 2, that's 22. Second thing here times second thing here is negative 22. Are y'all feeling a little better with the matrix multiplication? And then this answer, second row, second column, that's where that position is. So that's what I'm multiplying over here. Second row, that did not go very well. Second row, second column. First thing times first thing, 4 times 3 is 12. Second thing times second thing is negative 11. So here's what that matrix looks like now. Negative 11 plus 12, 1. Negative 6, 6, 0. 0, 1. Was I looking for that? Yeah, so I like that. Yeah. How come I can't just stop right now and say done? I have to check the other direction as well. So take a minute on your own and do the other matrix, bless you, multiplication. So it's B times A. And I'm going to do attendance real fast while you're doing it.